Good afternoon. We're going to keep working on section 9.6 today. In section 9.6, what we've talked about is how we can use our trig ratios to do something a little bit different in our triangles. And the idea again is to think about trig ratios and their inverse. So being able to work the trig ratio essentially backwards. So just as in junior high school, where we learned that adding and subtracting were inverse operations, meaning if you thought of a number and added 11, then subtracted 11, the plus and the minus 11 cancel each other out. It gets you right back to where you started. Multiplying and dividing are inverse operations, right? You think of a number, multiply by 4, divide by 4, it gets you right back to where you started. It's like the multiplying and dividing cancel each other out. And then the third one that you guys know of is raising to a power and taking a root. So if you thought of a number and squared it, then took the square root, it gets you right back to where you started. It's like those two things cancel. And then of course we have something similar with the trig functions. We can take the sine of a to figure out a ratio. We can take the sine of an angle like a to find the ratio of sides. And if we want to go the other way, we use what's called the inverse sine. If we have the cosine of r, that's going to give us the cosine of the angle r, so that's going to give us the ratio, in this case of the adjacent and the hypotenuse. But if we wanted to do it in reverse, we take the inverse cosine. If we have the tangent of v, that's going to give us the ratio of the opposite and the adjacent sides for this angle v. But if we wanted to do it backwards, we do the inverse. And remember the little -1 superscript, little -1 up here, tells us that that's the inverse trig ratio. Okay? All right. Now, if you're going to watch this video, if you're going to pay attention, you're going to get done with more than half of your assignment. I'm going to do more than half of your assignment for you. Okay? Now, the first part that we're going to do is remind you how to actually use your calculator, right? And we're going to do numbers 6, 7, 8, and 9. And what we're being asked to do is find the measure of angle D given the different trig values. So in number 6, as an example, this one says that the sine of D is equal to 0.19. And what we want, what we want to get as a result is we want to get to angle D is equal to about how many degrees. It won't be exact, it's going to be an approximation, but we want to know how big angle D is. The way we do that is we want to get rid of the sine, right? To get rid of any operation, if we saw subtraction, you'd do addition. If you saw multiplying, you'd do division. If you saw a power of 2, you take a square root. So if we see a sine, we have to do the inverse, which is the inverse sine. So we take the inverse sine of the left side, and whatever you do on the left side, you have to do on the right side. Let me highlight that to make sure everyone's okay. Whatever you do on the left, you have to do the same thing on the right. Now, because sine and inverse sine are inverses of each other, they cancel each other out, and you're just left with the angle D. On the other side then is the calculator problem that I showed you yesterday, right? And there, that's asking us to find the inverse sine of 0.19. Now remember, to get to this inverse part, to get to that inverse part, we have to hit the button on our calculator that says second, and then we have to hit the correct trig button. So we'd have to, in this case, hit sine. So when you turn your calculator on, it's second sine. You see the little -1 superscript, then you enter 0.19 and hit the equal sign, and all of us should get approximately 10.9 degrees. Okay, so that's the angle. 10.9 degrees is the angle whose sine is 0.19. We'll try a couple more. On number 7, we want to figure out how big angle D is. So we want to get rid of the cosine, and to get rid of cosine, we do the inverse, which is inverse cosine. And whatever you do on the left side, you have to do on the right side. So we also take the inverse cosine. Let me choose my highlighter tool again. Whatever you do on the left, you have to do on the right. So we take the inverse cosine of both sides. On the left, the inverse cosine and the cosine cancel, leaving us with just the capital D. And on the right side is the calculator problem, inverse cosine of 0.33. So again, what you're going to have to do is hit the hit the wrong key there. There we go. So what you're going to have to do is hit the button that says second, and then in this case, cosine. So when you hit second cosine, you'll see your calculator display the little -1 superscript. And when we punch that out, the second cosine or inverse cosine of 0.33 gives us an angle of about 70.7 degrees. Okay? So let's just bop out number 8 and 9. Again, we're trying to get to angle D being equal to. So to get D by itself, we want to get rid of the cosine that's attached to it. So we take the inverse cosine of the left side, and whatever you do on the left side, you have to do the same thing on the right. So the inverse cosine and cosine cancel, leaving us with D. And on the right-hand side, the inverse cosine of 0.64 is approximately 50.2 degrees. And finally, this number 9 problem. Again, we're trying to get D by itself. That looks terrible. Hang on a second. There we go. We're trying to get D by itself, so we want to get rid of the tangent that's attached. So to get rid of tangent, we do the inverse, which is the inverse tangent. And whatever you do on the left, you have to do the same thing on the right. So the inverse tangent and tangent cancel, leaving us with D. And finally, this number 9, the inverse tangent of 0.28 on the right-hand side gives us an angle of about 15.6 degrees. Okay? Alrighty, so inverse trig functions will tell us the angle whose ratio is given to us. Okay, so there's 4 of your first 6 problems. And then next I'm going to jump to number 13. And number 13 asks us to solve. And just as we did last week, solve means find all the missing pieces. So right now we're given 3 pieces. We're given that angle Y is 90 degrees. We're given this side of the triangle is 3. And we're given that this side is 9. So we're given 3 parts, at least one of them is a side, so we can find the missing pieces. Now the easiest missing piece here is to find the missing side x, little x. And that's okay because we know 2 out of the 3 sides. I just need to highlight for everybody that across from the 90-degree angle is the hypotenuse. And so whenever we know 2 out of the 3 sides, we can use Pythagorean theorem. So therefore we'd have leg squared plus leg squared equals hypotenuse squared, right? And we can punch out the math, 3 times 3, 9 times 9, move plus 9 to the other side by subtraction, and get rid of the power of 2 by taking the square root of both sides. So x is going to be the square root of 72, which is approximately 8.5. So there's one of our missing pieces. Doesn't require any trig, just Pythagorean theorem. Okay, now the other 2 missing pieces are angles x and z. So just for the heck of it, I'm going to pick x to find first, just because it comes alphabetically first. And to do that, I need to label the other 2 sides. I already have hypotenuse labeled, but now the opposite side is going to be the little x, and that makes the 3 the adjacent, right? Now to find the measure of angle x, what I'm going to do is I'm going to pick the trig ratio that involves the 2 sides that I was given. I was given the length of the hypotenuse, and I was given the length of the adjacent. And when you guys put those 2 together, adjacent and hypotenuse, only one of the trig ratios involves those 2. Adjacent, hypotenuse. Look back in your notebook. The only trig ratio that involves those 2 is cosine. So the cosine of capital X is going to be equal to the adjacent side divided by the hypotenuse. And when we fill in the adjacent side, 3, and the hypotenuse, 9, we have our trig equation. As I mentioned yesterday, please notice where the variable is. The variable's right there, it's the angle. So to get this angle by itself, to figure out what this angle is, just like we were practicing on numbers 6, 7, 8, and 9, what we have to do is get rid of what's attached. And what's attached to x is cosine. So to get rid of cosine, we do the inverse, which is the inverse cosine. And whatever you do on the left-hand side, you do on the right-hand side as well. So on the left, the inverse cosine and cosine cancel, leaving us with capital X. And on the right-hand side is the calculator problem, the inverse cosine of 3/9. So remember, with inverse, we have to use the second button. So this is going to be second, and in this case, we need to use the cosine. And then we have to enter into our window 3 divided by 9 and hit whatever you guys have, either the equal sign or the enter, whatever you have on your calculator. Okay, so what we'll have is the inverse cosine of 3/9, and we should all get an angle of about 70.5 degrees, approximately 70.5. Okay? All right, and finally, the last missing piece that we have to find is angle Z. Now you might think, oh geez, I've got to go through all the trig stuff again, but I actually don't. As long as we remember that, the 3 inside angles will add up to 180 degrees. So if I start at 180 and I subtract away the 2 that I know angle Y is 90 degrees. I know angle X is 70.5. Whatever's left then has to be angle Z. And when I do the subtraction there, 180 minus 90 minus 70.5, I believe I get 19.5 degrees. Okay? And there's the 3 missing pieces. So again, that was number 13. If you need to, feel free to pause the video so you can get all of that work into your assignment. All right, feel free to pause. Otherwise, I'm going to move on and do the number 14 out of your book. Right, number 14 is a triangle where we once again know 3 parts. We know this angle at H is 90 degrees. This side is 14, and this side is 16. So we're trying to find the 3 missing pieces. The easy one to start with here is to find side G, because we know 2 out of the 3 sides of the triangle. So whenever we know 2 out of the 3 sides, Pythagorean theorem. I'm just going to highlight for everybody, directly across from the 90-degree angle is the hypotenuse. So therefore, Pythagorean theorem is going to be leg squared plus leg squared equals hypotenuse squared. And we dig out our calculators. 14 times 14 is 196. 16 times 16 is 256. So we'll move our 196 to the other side by subtraction. And I'm going to double check so I don't mess up the subtraction. Yep, there we go. So we get 60. And to get rid of the power of 2, we take the square root of both sides. So G will be the square root of 60, which is approximately 7.7. Right, so we have our missing side. No trig required, just Pythagorean theorem. Okay? Then, to find one of the missing angles, and again, I'll just be boring and I'll go alphabetical here, so I'm going to find angle G first. I'm going to label the other 2 sides. So directly across from capital G is going to be the opposite side, and then the side that makes up the angle is called the adjacent. And what I need you to do is then pick the trig ratio that involves the 2 sides that were given. The reason we don't use the opposite side is just in case we made a mistake with the Pythagorean theorem, we can still get the question right by using the 2 that were given. All right, so what we have is the 2 sides given are the adjacent and hypotenuse. And again, there's only one of the 3 trig ratios that involves adjacent and hypotenuse, and that one is the cosine. So the cosine of capital G is going to be equal to the adjacent side divided by the hypotenuse, Our adjacent side is 14. Our hypotenuse is 16. All right? We want to know what capital G is, the angle. All right, so to get G by itself, we have to get rid of cosine. So to get rid of a trig function, trig ratio, we do the inverse. So to get rid of cosine, we do the inverse cosine of both sides. So that on the left side, the inverse cosine and cosine cancel, leaving us with capital G. And on the right-hand side is the calculator problem. I hope these are getting better. When we take the inverse cosine of 14 over 16, we get an angle of about 28.9 degrees. Okay, and then to finish off, the last missing piece is angle J. Again, you could go through a bunch of trig to get there, but you don't need to. If you remember that the three interior angles add up to 180 degrees, if we subtract away the two that we know, angle H is 90 degrees, angle G is 28.9 degrees, so whatever's left over then has to be angle J. And when we do that subtraction, we should end up with approximately 61.1 degrees, and we have our three missing pieces. Okay, so I've done number 13 for you in your assignment. I've done number 14 for you in your assignment. I'm then going to leave number 15 and 16 for you. And I just want to highlight that both 15 and 16 go back to last week, because in both 15 and 16 you're given two angles and one side. So we're going to go back to where we were last week using the regular trig ratios, not the inverse, but the regular ones. So hopefully that'll be a little bit of a review for everybody. And then the last one I'm going to do for you is the book problem number 20, right? So again, feel free to pause the video if you need to, so you can get a little bit of the little bit of the problem written down. But what's going on is this person's up on this bridge. They look down at a duck in the water. They measure the height above the guy's feet, the distance the duck is away from vertical, and they create the triangle that you can kind of see. It's a little tough, but you can kind of see in red. And then the question they ask us is, what's the measure of the angle at the duck? So they want, in fact, let me put that in red so it's a little brighter. They want to know what that angle is. All right? They don't need us to find all of the missing pieces of the triangle. They just need us to find that one angle. So what we're going to do is label the three sides of the triangle. So across from the 90-degree angle is hypotenuse. Directly across from the angle they want us to work with is opposite. And that would make this side the adjacent. Okay? And now what we need to do is then select the trig ratio that involves the two we know the length of. And the two sides that we know the length of are opposite and adjacent. Which trig ratio involves opposite and adjacent? There's only one of them, and it is tangent. So the tangent at the duck is going to be equal to the opposite side divided by the adjacent side. Our opposite side is 12, and our adjacent side is 7. Okay, so the tangent of D is equal to 12 over 7. We don't want the tangent attached, though. We just want plain old D. The question was, what's the angle from the duck up to the person? So we just want D. So to get D by itself, we want to get rid of what's attached, which is tangent. And to get rid of a tangent, we do the inverse, which is inverse tangent. So whatever you do on the left side, you also have to do the same on the right side. So the inverse tangent and the tangent cancel each other out, leaving us with capital D. And on the right-hand side then, we're left with the inverse tangent of 12/7. And that should get us an angle of about 59.7 degrees. Okay, so there's one more problem involving steps that will require trig. And then the last two problems, 31 and 33, are both problems from earlier in the chapter. One is just a simple cross-multiplying problem. And then 33 is one where you have to figure out which triangles to use, small medium, or big. Okay, so I'm just leaving you with a couple of problems. Let's see, which ones are they early? 1 and 2, those should be really easy. And then 15 and 16 are review questions. 21 is going to be a little bit tougher, but you can give it a try. Just attach the two numbers to number 21, the 7 and the 11. You should hopefully be okay. And then 2 review problems in 31 and 33. Okay? Otherwise, I'm going to be back tomorrow. We'll do some more of these, go through some questions, and then we're heading towards the test at the end of the week. All right, so see you tomorrow.